Cool. So I actually ended up getting a question the other day on solving absolute value functions. This is sort of an algebra thing. So as most of you know, when you have an absolute value, whatever value that you ultimately have inside the absolute value makes it positive. So you almost treat it the same as parentheses, but you still have sort of an order of operations to kind of go through first. And so the example I have here is I have 2 multiplied by the absolute value of 3x minus 5 halves, and absolute value is equal to 7. So this might look a little weird and maybe look a little hard. And honestly, it's because you essentially have a function inside the absolute value here. So you can think of this as some function f of x, really. And what I like doing is I like setting whatever is inside the absolute value equal to, say, f of x. But if you let f of x equal to, say, something like y, now really what you have now is you make the problem a little bit easier. So you have 2 absolute value of y, and absolute value is equal to 7. Well, if you treat the absolute value in here kind of like a parentheses, you can divide both sides by 2, in which case you get the absolute value of, make that green again, get the absolute value of y, and the absolute value is equal to 7 halves. Cool. So like I was saying, whatever number is inside the absolute value, whether positive or negative, it's going to turn it positive. So if you have some variable, is equal to 7 halves, the absolute value of y is equal to 7 halves. There's only 2 possible answers that y could be. So this means that y is either 7 halves, or it's also negative 7 halves, right? Because whatever's inside the absolute value has to be positive, right? So that's cool. However, our biggest thing is that we weren't asked originally to solve for y. We were asked to solve for x, right? But we do have a formula to translate y to x, right? Because this whole equation here inside the absolute value, inside the original one, the 3x minus 5 halves, happens to be equal to y, right? So just write it down. So y, actually, let me make this easier. Let's just do 3 minus my awful handwriting. 3 minus 5 halves is equal to y, right? And so because we have 2 values of y, we're also going to have 2 values for x, right? So our first one is going to be 3x minus 5 halves is equal to 7 halves. And then our second equation is going to be 3x minus 5 halves is equal to a negative 7 halves, right? So let's go for it. So let's add 5 halves to both sides of the equation. It's nice how this works out. It's equal to, it's going to be 7 plus 5 2. So we have 3x is equal to 12 halves. 12 divided by 2 is 6, which means x is equal to 3. It's going to be our first solution. X is equal to 3. So again, this one's going to be the same thing, except we're going to have 3x is equal to, it's going to be a negative 7 plus 5 over 2. 3x is equal to, it's going to be a negative 2 over 2, which is just negative 1. We're going to have x is equal to negative 1/3. Right, cool. So the biggest thing here is, at least I think, is take whatever value you have inside your absolute value, turn it into y, solve for y, and then plug it back into x. Remember, you're going to get 2 equations, right? Because you're going to get 2 different values of y. You're going to get 2 different values for x.